All right, this video is going to be a short tutorial on how to solve this simple two-dimensional problem using CMG. And what we're going to do is we're going to start with the input file from our one-dimensional example from a previous recording. We named that file testproblem.dat, and what we can do is actually edit this in Notepad, edit the input deck. As you become a more experienced CMG user, you'll often edit the notebook. You'll often edit the input deck itself. As you get more experience, you'll begin to learn what these various keywords are and how to edit the input deck, and that can make setting up a problem much faster. So the first thing, in our original example, we had 5 grid blocks in one dimension. So in this problem, we have 12 total grid blocks, 3 in the X, 3 in the Y, but we also have this constant pressure boundary condition over here. And so just like we did in the one-dimensional example, we need to include additional kind of very small fake grid blocks that we're going to put wells in, and that will allow us to add the constant pressure boundary conditions here. The no flow boundaries on these sides will be implemented by default. You don't have to do anything to get that result. Okay. So what we're going to do is we're going to start on the line where we set up our grid, and instead of having 5 in the X direction, we're going to have now 4 in the X direction, the 3 real ones plus the 1 small fake one that we're going to put there, as well as 3 in the Y direction and 1 in the Z. Okay. Now for this problem, our length and height are both 10,000 feet, so we'll need to change that. So we have 3 grid blocks. If we divide that by 10,000, then each grid block is 333.33 roughly, and then we'll have a 1-foot grid block again over here on this edge. Okay. We also need to then have the similar thing in the Y direction. This time we'll have 3 times 3,000. 33 feet, 0.33, and then in the Z direction we want to have our depth is 20 feet, so we're going to say all 12 grid blocks will have a depth of 20 feet in the K or the Z direction there. Again, the top, we need to modify that. Now we have 12 total grid blocks, so we'll put that there. For the permeability, now we're going to have permeability in the I direction is going to be 3 times 50 and then 80,000, and then 3 times 50 and then 80,000, and then 3 times 50 and 80,000. Again, that's because we're putting them in the order here. So the first 3, 0, 1, 2, 3, or 0, 1, 2 will be 50 millidarcy permeability in that direction, and followed by a very high permeability grid block here, 80,000, and then again 350, and then an 80,000, and then 350, and then 80,000. Right? So for the J and the K direction, we'll just use a constant grid block, or a constant value of 50. And so with that, we should be able to then save this, and I'm going to save as, and change the name to test problem 2D. So we'll save that. Close out of there. Now we have this test problem 2D. I think we need to make sure the file extension is .dat. I should have done that when I saved it. But now with this, we should be able to drag this into Builder. And if we didn't make any mistakes, now we see our two-dimensional grid. Now we do have this well here because it was originally placed in the 1D problem. It was originally placed in the first grid block. So we see it here, but we want to move that over here to this other grid block. And so the way we can do that is we'll go to the Wells tab, Click on the perforations tab, and the grid block location we want will be 4, 1, 1. So the fourth grid block in the X or I direction, and then the 1, 1. Right? And so now you see the well has been moved over here. And so we just need to add now 2 more wells. So we'll go well new, and we want them to be injector mob weight. We want the constraints to operate at 2000 psi. Just make sure that this injector fluid is water. Sometimes I believe there's a bug or something that causes that not to be displayed properly. So for this well 2, again, we want to go to the perforations tab and insert the well, this time into the 4, 2, 1. Apply right, again, it's the fourth grid block in the X direction, the second grid block in the Y direction there. So you can see the second well, and then we'll just repeat those steps for a third well. This time placing it in the 4, 3, 1 grid. And there we see it. So now we have the 3 wells that are supplying our constant pressure boundary condition on the right hand side. So with that, we should be ready to run. So we can just go straight to validate with IMAX. We want to run normal immediately, and we can run. We got an abnormal termination here. Let's see if we can figure out why. Looks like there's an error in the wells and recurrent. Probably, again, this has to do with the this issue of injected fluid not being selected. Even though it appears to be water, sometimes you have to go in there and actually set it. And now you see there's a green check there. There was a red X I didn't notice before. So again, now we should be able to run it. Validate with IMAX, run normal immediately, and we see we have a normal termination. So with that, we can go ahead and close, and we can close out of Builder. And go ahead and save the changes to that file. So when you run it, it produces these 2 files, the .out file and the .sr3. This .sr3 you can bring into results. So that allows us to then have a look at the results. If you go down here to aerial view, you can see an aerial view of the reservoir. In this case, if we go to display, we can select what we want to display, pressure. You can actually play it through time. In this case, there's only 3 days. So in the last day, you can see the pressure distribution there. If we wanted to say, look at how the pressure changes over time in any one of these grid blocks, you can right-click in the grid block. You can say quick plot block property, and that will pull up a pressure versus time history for that grid block, and you can see that there. If you'd like, then you could say export to Excel. That will automatically open it up in Excel, and then you could from here then save it as whatever you'd like. I like to save them as CSV files right there. So that's how you can export some data from the simulation if you'd like. So I think that'll go ahead and conclude this short tutorial on using CMG for this 2D problem.